Bardou is a technical director and the planning department and for Vinci Autoroutes in France. And this is the four Eurostrat talk. And for the first time today, we'll have someone that is from the owner part. So after some academics and managers, today we'll have the perspective of the owner, because Nicolas has a long experience on this. He has been first working on the construction, and after that, with all the knowledge of this and the background of the construction law, he moved to more the management and the bridge program from the owner perspective. He has been working for that in the last 8 years, so he has a very nice experience on that. And also today, he's working with the asset management strategy in the Vinci Autoroutes context. Of course, he's member of many associations. Most important, probably, he's member of PR in the bridge committee, and also he's member of other important organizations in France. And very important for us, he was a very active member of the Industrial Advisory Board of our construction TO 1406, where he shared with us his long experience from the point of view, from the side of the owners and of the manager of bridges. So with all this background, I expect a very good talk. That will be for sure on this subject of the water high performance concrete for the repair, the strengthening of structures. So Nicolas, when you are ready, you can start.
Thank you very much, José. Thank you very much, Juan, for this very impressive introduction. Yes, I am as honor. I will share with you some recent experiences that we have in Vinci Autoroutes regarding what kind of innovation system we implement in order to save some really serious problem we have in one kind of bridges that we have to deal with, which is the soil steel structure. So before maybe to enter in this subject, I will so give you a little introduction regarding France, regarding Vinci. France has more than 1 million kilometers of roads, including 20,000 kilometers of highways. Half of these highways is granted to private operators. We have financed, designed, built, operated, and maintained the highways network. The first concession contract dates back to the development of the first ultra-urban highways in France, late 50s, early 60s. Vinci Autoroutes is the leading European motorway concessionaire, operating half of the French concession network, more than 4,400 kilometers of motorway. As such, Vinci Autoroutes managed over 6,000 motorway bridges, including nearly 250 viaducts. Vinci Autoroutes operates through 3 main companies, as you can see in this map. The biggest one is ASF in the south. In the Riviera, there is Escota, and Cofiroux network near Paris. So, regarding this first context that I explained, and to cope with the urgent need of new infrastructures in France, many innovative techniques have been implemented on the French national road network, with in the background the search for economic optimization and speed of design and construction. And this is how steel culvert was born. But what is a steel culvert? This is a bird steel culvert. It's a composite structure consisting of a flexible metal structure made of corrugated steel assembled by bolting, which is embedded in a compacted embankment. It can be used as an hydraulic structure in drainage system to restore waterways and so on, or as a dry structure to restore roads or agricultural traffic on the fauna path. Bird culverts are recognized as a bridge for diameters exceeding 2 meters, according to French standard. And some of them have an opening greater than 6 meters. So their use was really widespread because this type of structures was simple, quick, and inexpensive to build, while offering longitudinal flexibility to tolerate profile misalignment and having a good ability to carry large load, which is very important. And the structures have flourished in France from the 70s to the middle of the 80s. But this heritage is confronting serious problems. Steel culverts were generally located in unfavorable environments with the presence of water or aggressive soils, with the transport of solid elements, which cause degradations of the culvert at the level of its walls, in the tidal area, and of its raft. Corrosion can also be very important on the backfit side, and therefore not detectable during the visual inspection. The infiltration of water, loaded with de-icing salt, for example, through the embankment from the platform, is also a factor of accelerating corrosion. Overall, the national heritage of metal culvert is aging. Many of them is approaching 35 to 40 years, which is their actual lifetime from a survey of manager of the national road networks. For example, some manufacturer catalogs expect 25 years as a lifetime for this kind of bridges. The steel culverts are part of sensitive bridge families identified as having a risk of sudden failure given their design on their side. So, at the French level national, we estimate about 3,000 buried steel culverts, and 1/3 of them are in the Vinci Autoroutes network. So I know I will give you some information regarding the way with the way that the coffee would deal with this kind of problem. We have by now a focus in one of the three national networks, and this is near Paris with a lot of de-icing salt. We decided at the late of the 19th, following alarming diagnosis that the whole program was to complete the total replacement of all structures. And in this network, we have about 120 culverts. So we did a multi-criteria analysis to assess the disorder and prioritize the action. Prioritize the action, And to date, more than 50 culverts have been replaced. To give you an idea, the cost of replacement is from 200,000 euros for a little diameter to more than 2 million euros for a bigger, a larger one, and the cost depends also of the hydraulic and the environmental constraints. Today, this type of operation is extremely complex. In addition to the intrinsic complexity of the technical problem, the environmental constraints and the resulting administrative authorizations force the maintenance manager to intervene as fast as possible, not leaving any room to improvisation. But the risk is important when the work is in progress. We are looking for fast, quick, economic, clean solution, and which guarantee robustness and long-term durability. The three options considered today are composite liners, reinforced concrete form, and pour and dry shotcrete. A common point between these three techniques, the existing culvert is assumed to be non-participating structurally. In other words, it's a replacement. The main method implemented in this network is the PVC or the glass reinforced plastic casing. The objective is to insert prefabricated composite pipes inside the existing culvert section, provided that the misalignment of the existing culvert is not too pronounced to be possible. The annular void is then filled with a cement grout. This process is quick to implement, clean, and allows to limit the time of intervention, in particular on hydraulic culverts. Its main drawback is the significant reduction of the hydraulic section, compensated by an improvement of the manning stricter coefficient of the surface, leading to an increase of the flow speed inside the culvert. Besides, the water level is also increased. It should be noted that it's no longer really relevant to significantly reduce hydraulic section due to climate change. This is therefore necessary to provide special arrangement at upstream, for example, to cope with the ups and downs caused by the water, and the shallows to dissipate energy. Another disadvantage, this process is restricted to the smallest diameter. We can expect diameter about 3.5 meters for this technique. The second methodology used in this repair of metal culvert is reinforced concrete. This technique is more than mastered and simple to justify by calculation. It can repair culvert of any diameter. The typical wall thickness is 200 millimeters, and therefore it reduces the hydraulic section, but requires less development and the downstream and upstream areas. However, the one-seat work are substantial. Reinforcement, formwork, and concreting works lead to a long planning, often incompatible with the allocated period of intervention. To reduce the duration of work, it's possible to provide more formwork to improve the construction cycle, but these pieces of equipment are very expensive and difficult to amortize on relatively short culvert lengths. In average, our culverts are a few tens meters of length. At last, the management of the risk associated to flooding events is very random. The third repair method, classic repair method, is the implementation of dry shotcrete. This technique offers the advantage that it does not require the use of formworks and can accommodate the local deformation of the culvert, in particular inverted profile, for example. However, it requires the installation of reinforcement beforehand and generates a large volume of waste due to rebound of aggregate against the steel sheet, up than 50% of loss. That material must be disposed in landfills, which is also a cost, and the work have a significant environmental impact. And you can imagine this kind of work in an hydraulic section. So a new solution appeared really recently, less than 1 year. This is the UHPC, the sprayed UHPC. This new solution has been developed very recently in France and developed by two companies, two French companies, Lafarge and Fraissinet, which is one of the Vinci company. This is extending the family of cast of UHPC. Exceptional strength and durability. Innovation lies in the high thixotropy of the material, do not debond or sag when applied to the ceiling of the vertical surface, and the putting and spraying technique. The main advantage is the speed of implementation without reinforcement work, the preservation of existing clearance of improvement, the Manning-Strickler coefficient by the filling corrugation, no more modification of water level, less environmental impact, and little loss, about 10% rebounds versus more than 50% to the conventional dry Shotcrete. But there is some application condition. This is limited for a 2 meter, minimum 2 meter opening. It needs a very good quality of backfill, and I explain why after. And it's not possible to apply when we have inversion of curvature. So it implies preparation work if your culvert have some inversion curvature. So I made this presentation is not regarding UHPC, but the idea of this innovation was to fit with all the UHPC structural characteristics. So I thought, I don't know if this presentation will be available on the raw structure, but you can have the main, the remaining of the main property of UHPC. So what is the concept of this innovation? The main innovation is based on the thixotropic behavior of the sprayed UHPC, but also in the implementation process, mixes, pumping, and spraying. On the one hand, the rheology has been engineered so that the layer of UHPC does not sag when sprayed on the wall. No stiffening admixture are needed, which makes the solution robust. And the other hand, a specific equipment has been developed to mix, pump, or spray this highly thixotropic material, which mechanical properties are enhanced by the spraying process, in particular the compression strength. There is low air content. The concept is to reinforce works mechanically as a composite using the interaction between the soil and the UHPC structure. This is not as the traditional technique replacement. We take advantage of the soil structure solution. If the soil is not too poor stiffness, the composite will be not work efficiently. It is therefore essential to know the nature and the strength of the embankment. Really more than for the other solution. It's also necessary for the other, but less. Another advantage is the optimized steel fibers alignment in the wet process in place of the sensitive stresses. When we compare this process with the other one, we can see that it's particularly advantageous. The hydraulic section is practically not reduced. The water line remains unchanged. The execution time is optimized, and the durability is theoretically, because we have to improve, very good. It will nevertheless necessary to demonstrate. So the development of this crate followed the following path. The first path, it was necessary to work on the formulation of the material, rheology, adhesion, mechanical performances, as well as the development of the specific method of equipment for mixing, pumping, and spraying the material, while controlling, and maybe one of the most important issue was the control of the fibers orientation and the percentage of loss was maybe the main challenge. The second path was laboratory tests to characterize the material according to the French standard for cast UHPC, compression, tensile strength, and I guess that in the audience there is people from the Université Gustave Eiffel. It was ISTAR. This French National Laboratory accompanied this process of design. The purpose was to confirm that the material can be classified as a UHPC for structural application. The third part was the numerical models, and it was developed 3 numerical models in order to perform with calculation according to Autoroutes. The first model was a simplified approach to pre-design. The second was a linear approach, and the third one was a non-linear approach with the soil springs and the explicit soil modeling. The following path was the modeling have to be validated as a full-scale test. A new steel pipe reinforced with sprayed UHPC had been lowered to failure. At least, the technology was implemented on experimental structure, a dry culvert of about 20 meters length was the solution of the calculation method were approved by Ductal and Freycinet as the main owner of this innovation, but also by the French National Technique Services, and finally by the technical services of Waterways concessionary. We have to also improve this calcul, and we also submit to the grantor authority. It took more or less 24 months to complete all the steps. So by now, I give you the case study, the reinforcement of a bridge in the coffee route network in Paris, and well, I have to say that innovation is in the DNA of Vinci Autoroutes. So when Freycinet partnership proposed to experiment this promising new technique, I naturally seized to this opportunity. We choose a structure near Paris on the A10 motorway, which is one of the main French motorway, with nearly than 80,000 vehicles a day. It was selected for this first implementation because the culvert is a dry structure which will allow an easy monitoring of the reinforced structure behavior at a young age. And it was really important to be able to be sure of this monitoring. The culvert is about 40 meters length, with a circular shape, diameters of 2.7 meters, built in the 1971. The UHPC reinforced has a mean thickness of 75 millimeters. The sprayed HPC is also coated with a thin mortar 2 centimeters to embed the protruding steel fibers that may hurt the user. The main geometric and functional features are recorded on the side. You can see. So the main steps of this process were first the site investigation of studies. When we said the soil investigation are really important for this concept. And all the calculation are also really important. And you can we can verify all the calculation hypotheses regarding the soil investigation result. The second step was the works with the casting of the raft in reinforced concrete with a flat surface for the traffic, cleaning and preparation of the surface by a light abrasive blasting, construction of the UHPC shell with production of 6 rings a day, and all this work were controlled by my services, and also we give a mission to a French national agency to help us in order to lead this process. And we also decided to monitorize during 10 years the deformation of this bridge. There is a lot of control, compression test and the blending test, and our main issue as an owner is the sustainability and operability. So maybe we can put also in perspective the other potential application that we can imagine with this process, and we can imagine that it could be used as a strengthening of concrete structures, rehabilitation of maritime structures because of the good resistance to corrosion, rehabilitation of hydraulic structures, and tunnel lining also. Regarding the process, it's really possible to have a process more industrialized that we applied in our road, in our bridge. And I know that the team, Freycinet Dutal, is implementing a very good automatization implementation with an 80% automated operation. Mixing station, pumping station on the water treatment would be completely automatic. That challenge is steady production and pumping in order to have a continuous spraying. So to conclude my presentation, I can say that for us and maybe in 30 years, we have the problem of this metal culvert bridges due to corrosion. We implement a lot of solutions, but maybe regarding the really strong constraints regarding environmental issues, the shield sprayed UHPC could be a really good solution for us. And we also can imagine maybe the extrapolation of this solution for other reparation, other repair, other maintaining. So I finish my presentation. I'm sorry for my English, which is not as good as I would like, but I think that I guess that it will be enough to be understood, and I am available to answer your question.
Thank you, Nicholas. So it was very, very interesting question and dealing with a very relevant point and fact that I imagine it's not only on Vinci. I imagine that many other concessionaires and the road operators are facing this issue nowadays. I would like also to remember people that are attending this talk to turn off your camera, and also that those questions, those who want to place questions, they can do it either on a Facebook or either here in the Zoom. But in the Zoom, I'm gonna ask you to do to place those questions on the chat. So feel free to put questions to Nicholas, but should be on the chat, and we will coordinate in this way. So, Nicholas, I think I have the right, or I'm gonna make you my first question. And my first question is concerning also the yearly maintenance planning, the costs that you have with the culverts compared with other. What is more or less the relevance in terms of yearly maintenance costs? And also the other thing that I want to ask you is if you are using any kind of criticality indicator or whatever in order to identify from those culverts that exist now, what are those that are in a more risky way, so you need to act now, or those that you need to act in a later time in a later period.
Yes. Yes, we we have according to the French standard and according to the way we have to deal with our bridge management, we follow all our bridges. We have a really strong inspection campaigns. We have, for example, each year summary inspection of our bridges, and we have complete inspections every 5 years by engineers. And for the most critical conception, we have more than visual inspections. We also size some, for example, we size the thickness of steel. In these structures, each year we size the thickness of the steel. And we can, mixing the observation of the corrosion that we are able to do with the visual inspection, mixed with the result of the corrosion sizing that we do each year, we are able to have this kind of analysis that you can see in the slide, which is a kind of hierarchy regarding the importance and the priority of our action. And according all this analysis, we are able to have a program of maintenance for this pathology. And 30 years ago, when we do the first check, we identified the most critical bridges, and we repair, of course, the most critical. And today, each year, we substitute and we replace some bridges according the list of priority we did 30 years ago, and we update each year. I don't know if I answer your question.
Yes, but in terms of impact in yearly costs, do you have an idea how much this represents to Vinci in terms of maintenance costs, the culverts compared with the other types of bridges and viaducts?
Well, I'm not able to give you some. Well, it's confidential data. But what I can say that we have on the Vinci network more than between 10 or 20 bridges of this kind replaced each year. And you know that I said in my presentation that the cost is between 200,000 euros. It's from 200,000 euros to more than 2 million euros, according to the size of the bridge. So you can imagine the amount. It's a really important amount. And you have to know that also, I think that I said in my presentation, that it's one of the sudden collapse possible of motorway. Fortunately, in Vinci Autoroutes, we didn't have this kind of problem. My job is to turn impossible this kind of collapse, but in France, we already have this kind of collapse.
Okay, thank you very much. Before I ask João to make the second question, I would like to ask all to place the questions to the Eurostruct Association account, okay? So in the chat, please choose Eurostruct Association and place the question directly to them, okay? Thank you very much. João, please.
Yes, thank you. Nicholas, thank you for your presentation. I appreciate very much that you focus on a structure that is not the longest span bridge and the very nice structure, but something that is important. And without this type of structures, these small and insignificant structures, also the highways will not work. I had some questions to you, but I prefer to pass first the questions from the audience, and if there is time at the end, I will make you my questions. So we have some questions already in the chat. The first one is there are two people that are almost asking the same question. It's Jose Carlos Patiño and Amir Kedar, and they ask about the type of preparation to be done in the surface of the steel before the spraying of the concrete.
The preparation is relatively simple. We have to I give you the presentation. It's basically simple. The preparation of the steel is only a light abrasive blasting to help the adhesion of the concrete, the UHPC on the steel. In some situations, we also have to put some steel networks to help at the most vertical places. And in the picture, for example, you have for the experience we did in the coffee route network. In some places, they put some steel networks it was not for structural behavior. It was only to help the adhesion of the concrete on the culverts. I guess that by now they work on the concrete formulation in order to not be necessary to put this kind of rate of network. Sorry.
Okay.
There is another interesting question from Amir Kedar regarding the quality control of the system, because we assume that what is very important to have the right thickness in all the parts of the reparation. So the question is, if you do this by man-made, probably the thickness is not very well controlled. What about using a Shotcrete machine with a laser guiding and so on to make it more automatic and more easy to control the thickness of the concrete?
The process we implemented in this work was a radar inspection in order to size the concrete, the thickness, and as a first experience, we have almost a continuous control. We reinforce a lot in order to be sure that there is no problem of thickness. Well, I think that this idea can be a good idea also. I can note, but what we did in this work was more radar and a continuous control by our team. But of course, it was an experimentation. As a run solution, it would be necessary to improve more realistic control implementation system.
Yeah, also regarding these first experiences, there is a question from François Toulemont. It's asking, what are the lessons learned from the first implementation? Warnings, aspects requiring care, for instance, supply chain of the ultra-high performance concrete, sensitivity to the temperature, and climatic constraints for implementation. And also, the last question is if you have the road in use during the reparation. Any questions in one?
Yes. Basically, the question is, what is our feedback?
Yes.
No, we do this work more or less 1 year ago. So we have not a long feedback, but during the works we already understood some good information. We have some problem of pumping, for example, from which define the new solution that Freycinet and Ductal will improve for the next works. But regarding, for example, the climatic condition, we choose the best time to do this work. We choose the beginning of the spring. So the beginning of the spring is good because it's not it's not too warm, it's not too cold. It's more or less the really good time to do this work. So we didn't have information. I have not, maybe Freycinet will tell out. I have not information regarding the impact of the really warm weather or really cold weather on this process. What we see after 1 year, we have not. The result is as expected. We have not seen any. The inspection didn't show something wrong regarding what we expect.
Nicholas, we have here a question also from the audience concerning what size of fiber are you using in this application? Do you have any idea
What size
of the fiber that you are using?
I have not this information. It was a really specific. I have not information. I'm sorry. It was a specific fiber. No, I'm sorry. I have not.
And there is another one concerning. Also, we were speaking about the preparation concerning how the corrugated sheet should be prepared before applying it.
It was what I said. It's only light abrasive blasting in order to give more adhesion at for the concrete and the steel, but nothing more. See, maybe I can give. There is one thing very important. This is the geometric constraints. It's not possible to apply this method if you have not regular curvature of the culvert. If you have some, maybe my English is not right. I give you. I have on my notes maybe the right word. Yes, it's not possible to apply this solution if you have an inversion curvature at the top of the culvert, because this is soil structure physical mechanical behavior. So if you have an inversion curvature, there is some mechanical dysfunction, and there is no possible. So if you have punctual inversion of curvature, it's possible to do preparation works in order to correct this inversion. Nevertheless, if you have a general inversion curvature, maybe the best solution is to implement another repairing method. I think that this method is good when you have all little inversion curvature or not inversion curvature.
Thank you, Nicholas. There is only one question I want to put, and I will ask Joan to continue. The last question is about the velocity of the concrete shooting. If you have any idea of that, what is the velocity value, and if it is also stable during the operation.
The velocity, I think that you mean what is the
velocity? Yes,
okay.
Of the shooting.
What we see is we how can I translate this in quantity? We were able to do more or less 12 meters of culvert a day. It was more or less 4 meter diameter. So the main problem we had in this process with the tool we had, it was that the preparation mix of shotcrete was quite long, and we were able to apply 3 or 4 preparation a day. So the problem was not so the application time, but the mix time. I know that today, after this experience, Freycinet and Vital worked on industrial process in order to turn quicker all this mixing process. And I believe that if without this limitation, it would be possible to do maybe I don't want to say something wrong, but more than 20 meters of culvert a day. I try to translate in a quantity, but it's maybe some no. Well, I don't want to say something wrong, so I will give you the information you can put on the site after. But it's more or less 3 times quicker than the shotcrete traditional solution.
Okay, thank you, Nicolas. Joan.
Yes, Nicolas, as you could expect, there are some questions related to the sustainability of the technique, no? Summarizing all of them, the questions is about if you are using other green and sustainable materials with the concrete or instead of the concrete. And the other one is what can be done to minimize the embodied carbon emissions on the high performance concrete.
So this solution is a way to use less to reduce the footprint, the carbon footprint, because the quantity of concrete, the quantity of cement is really less than in traditional solutions. So this is a kind of solution really virtuous, respecting carbon footprint. We also in Vinci Autoroutes, we also have some experience, but it's nothing to see with this this example. More in the new bridges, we are doing some experimentation with the low carbon concrete. It's quite new. We have some experimentation in progress, and the idea is to use cement done without clinker, so without oven, traditional concrete oven. So it's a reduction of energy needs of the progress of the process. But it's something we want to go on, and we have some experimentation in progress. I consider that the shotcrete UHPC is completely in this kind of strategy.
Okay, thank you, Nicolas. Another question is related that other subject is we have been talking about the steel, we have talked about the concrete, but there is another important ingredient here, that is the soil, no? So before the repair, how do you know of the properties of the soil, and how is this taken into account in the repair? project?
It's also it's maybe one of the most important conditions when I say that this is a soil it's a soil structure. So the property of the soil is really, really important. So we do some investigations. The investigation are basically did with I kept we do some investigation on the abutment of the embankments, and we analyze all the soil property regarding the strength, and it's necessary. I have some value. It's necessary to be better than 40 MPa. This is, yes, the soil modulus is necessary to be upper than 40 MPa. So we have to check this characteristic.
Okay.
Nicholas.
I
João, please go ahead.
Sorry?
Please go ahead.
Yes. The last question here in the chat is more regarding some chemical reactions. The question is, may the bond to galvanized steel be damaged by the development of hydrogen due to the reaction with the zinc with the cement?
Well, as a bridge manager, as an owner, I'm not a chemical, so I'm very sorry I'm not able to answer this question. But I believe that if you give me this question, I can check the answer with the people from Freycinet and Buchtal.
Okay, Nicholas.
Nicholas, we were speaking about quality control and using GPR. There is a question about if you check the homogeneity of concrete and also the voids ratio in the concrete, because radar is able to detect the voids in the concrete. If this was something that was checked with the GPR during the process of quality control.
Yes, we check as we did in this experimentation. We check in two steps. First, at the mixed process, during the mixed and before to be pumping, there is some control of homogeneity of the concrete, but really important homogeneity of the fibers inside the concrete. After the process, the pumping, one of the innovation challenge was to find all the pumping process in order to keep this homogeneity on the material in place. So there is really all what is really clever in this solution is the shape of the pumping will give the guarantee to keep this homogeneity and to keep also a right quantity of fiber in the right orientation regarding what we expect for a good mechanical function of the structure. So we have two control quality. The control quality is on the bald during the mixing in order to check the right quantity of fiber by per unity of concrete. And after, it checked by some carrots in order to analyze the homogeneity of samples on samples.
So you control the orientation of the fibers in the concrete, right? Through the GPF.
Yes.
Another question, Nico, is the process that you spoke about, is it a wet mix or dry mix sprayed concrete? And what components are mixed before spraying? You spoke about that previously, and there is a question about if it is a wet or dry mix and what components.
You speak of regarding the traditional technique.
Yeah, the spraying process of the concrete.
The dry spraying process.
Yeah, it's a dry spraying. Yeah, and what components?
It's in this situation. This is a relatively traditional composition of concrete with a limited granulate size, but you are not in this situation. It's only concrete without fibers, because in this situation you have to put your steel before to spray the concrete. So you have. Well, I don't know exactly what are the adjuvant, the special adjuvant that you have to give the good rheology. I don't really know, but there is no fiber adjuvant in this fiber addition in this situation.
Okay, Joel.
Yes. Well, I don't have more questions in the chat, so I would like to put my question. Is that after this experience, after all these years of using this system and all the problems that they appear related to the corrosion, the damage, and all the cost of to repair these damaged culverts, do you think that for new culverts this is still a good solution, or it will be better the traditional way of concrete, either in situ or precast concrete? What do you think about?
Well, in France, we didn't do more steel structure maybe 20 years ago. So yes, this is not a really a good solution for. It can do a lot of problems, but we still have a little quantity, but we have some culverts with 40 years in very good conservation state. But it was a situation without high salt sensibility. It was it was embankment without acidity. It was a lot of situation, but it was a kind of a good surprise, because all this situation, all this factor was not thought when these bridges were implemented, were built. To be sincere, today I'm not really fan of this kind of conception, because it's assumed at the beginning that is a conception where the corrosion would be really active since the beginning. And if you put this kind of structure when you have a tidal problem, it could be it's of course it's obvious that you would have some corrosion problem. Maybe if you choose an application, for example, for temporary bridge, if you have, for example, to implement side work, it could be a cheap solution. Yeah. But I don't advise this solution for long paths and for 100 years sustainability.
So, in summary, it's something that you have to take care of the existing ones, but you will not promote the use of new ones in the new constructions.
Oh, that's right.
Because probably if you perform a life cycle analysis of these structures, of course, they are probably cheaper at the beginning because it's very fast and very quick to build them, but then in the long time, the behavior is not, the performance is not good enough.
Yes, it's totally right.
Nikos, I have here 2 more questions, and then I will ask Joan to put the final question because we are already achieving the time. So the 2 questions that I have from the audience is the first one is if you compare the embodied carbon for a traditional sprayed concrete repair with a UHPC repair, if this comparison was made.
This comparison was made, but not. It was made as a ratio approach, but not really with a really deep study. And we checked that it was more interesting regarding the carbon footprint, but we have not really a rigorous value. I think that it's maybe the next step is to give the demonstration that and to be able to quantify this value and this gain.
Okay. And another question is, have you tried using UHPC as a matrix for textile reinforcing mortar to strengthen structural concrete elements? And how is its bonding performance with concrete substrate?
I don't really understand.
If you try using UHPC as a matrix for textile reinforcing mortar.
For
textile reinforcing mortar, in order to strengthen structural concrete elements, if this was already used by Vinci, this technique. In a strengthening of structural elements, structural concrete elements, if you have tried to use the UHPC as a matrix for reinforcing mortar.
By now, we have not used. We have some projects to use UHPC. Some of them are under. I'm not allowed to speak about, but other ones are use UHPC not sprayed, but as it was already done, it's not an innovation for reinforce the deck and to give the waterproofing characteristic. We have some bridges under study for this kind of use. We are also thinking using this kind of solution to reinforce some walls, but it's not. We have not achieved the demonstration that it's interesting.
Joan,
last question. Okay, so will be more. It will not be too related to the presentation from today. It will be a more general question regarding the efforts on the assessment and quality control of the structures. And it's a question that I want to point to you because you were a very active member of construction, working on the industrial advisory board with the owner's perspective. That is very important for us. And as you know, this has developed to this new association, this Eurostruck association that wants to develop this and take the momentum that we got from the action. So I would like to know, from the point of view of the asset manager and the owner, what is your opinion about this initiative of the Eurostruck, continuing the work, developing the cost action?
Of course, as a bridge manager and in the really rich and sad actuality that we had the past years, I think that all initiatives regarding the improvement of quality control and in order to have a better management of bridges in Europe looks really profitable. So it's and you said in the introduction, I'm also an active member in CARC, and all our works are also, as in Eurostruck, in the same direction, is to improve the safety for the user of bridges in a context that all European countries know today. We have more traffic. Well, it was not right during the 3 last months, but we have, in average, we have more traffic. We are more loading. We are more need of loading. We have bridges hold and holder, and we need to know, and we also have a really hard constraints, economic constraints, budget constraints regarding the bridges maintenance. All initiatives able to help owners, to help governments to optimize this terrific equation are welcome. So I think that all you worked, all your contribution, are the same as the CARC and YAPSE and the YAMAS and all this community is really useful today, and I think that it was maybe it will be more important tomorrow than it was 10 years ago.
Thank you.
Thank you. Thank you, Nicholas. So again, I would like to acknowledge for being with us today. It was a very, very interesting presentation with the technology to solve one of the biggest issues that concessionaires and operators have nowadays. And still there are some points that need to be improved for the future. And here we are as Eurostruck to discuss and try to find out solutions and networking for ameliorating the quality of the structures at European level, such as you mentioned. I would like to acknowledge you and Vinci. I'd like to acknowledge Joanne for being with me today on the moderation. I will only like to give you some information about the events of our associate partners. So concerning IAVSE, we're gonna have the IAPSI 2020 symposium on Wrocław. It was supposed this symposium to take place on the 20 to 22 of May, but now is rescheduled to take place from the 7th to 9th of October 2020. And the IAPSI task group meetings and welcome reception for participants will be held on the 6th of October 2020. So the early bird registration was extended until 15th of June 2020. The other information is about the IAPSI 2021 in New Delhi. If you did not submit your abstract, so the good news is that the deadline was extended until 31 of May of 2020. So it was last week, but you are still on time to submit your abstract. And please submit your abstract and visit and use opportunity to visit India. Also from FIB, as you are aware, the FIB in Shanghai was rescheduled to 20 to 24 of November 2020. So the abstract submission is still open, and also the early bird registration was postponed. So for those willing to go to Shanghai, is information that was rescheduled the FIB to end of November. With respect to Eurostruct, I would like to inform about the training course initially was supposed to be in Ireland, but now we took a decision to make it completely online, and this will be held from the 2nd to the 4th of September 2020. So for those which are willing to learn and have more knowledge about the quality control procedures which were discussed during the cost action 1406, you're going to have the opportunity to attend this online course and also to discuss with other colleagues from all over Europe and not only, and about these issues that we are facing nowadays concerning the maintenance and the quality control of our structures. Also, the Eurostruct 2021 conference in Padua, I would like to inform you that the launch for abstracts will be released this month. So it will be held from 29 to 31 of August next year. So those who are willing to submit an abstract, you are very welcome. It will be in Italy, in Padua, a very nice place also to go. And finally, I would like to use this last opportunity to invite you for our next talk that will be held with Helmut Wenzel on risk-based monitoring of existing structures, and it will be held on the 9th of June at 2 p.m. Central European Summer Time. So thank you very much to be with us during this session, and I wish you a very good day and a very good week. See you on the 9th of June, and thank you very much. Bye-bye.
Bye-bye, Jose. Bye-bye, Nicolas.
Bye, Joanne. Bye, Nicolas.